Hello, I am one. I know at the end of last week we've been told the shelter-in-place orders have been extended to at least the end of May. That's a few more weeks where we have to stay at home and continue to practice social distancing. The good news is that the state is beginning to loosen the order to allow some businesses to get back to work. This means gardening and construction are working again, and someday soon we'll even be able to get a haircut. We've been talking about inequalities, where we've been working to understand the concept of greater than and less than, as well as greater than or equal to and less than or equal to. We increased this idea to describe this by shading one side of a line on the coordinate plane. The lines are dashed to describe less or greater only, and a solid line when talking about less than or equal to or greater than or equal to. In today's lesson, we expand a little more to talk about two lines forming a system of inequalities. Think about what this might mean. If two distinct lines are drawn on a coordinate plane, that coordinate plane is now divided into three regions or four regions. So here, I'm going to draw in a way that we break it into three regions. So here's two lines, and notice now I have one region, two regions, three regions with which we can talk about where the points lie. In another situation, we can break it up into four regions. So say we have a line like this and maybe another line that goes like this. And notice when we do that, we break things into four regions. 1, 2, 3, 4. All the points in these regions are determined when they make truth for both sides of the linear inequalities. So for instance, take a look over here. If I have a point in region 4, then all of those points, their ordered pairs, will be truthful for both of those two lines right there. Similarly, if I had a point in region 2 of the first graph, I have a point, several points actually, whose ordered pairs make truth for the inequalities involved in that drawing. The following is a system of linear inequalities in two variables, those variables being x and y. And I want you to notice too that these are written in standard form, which means we need to transform them into slope-intercept form in order to graph them. So let's take the first one, x plus y is less than or equal to 6. I'm going to subtract x from both sides, and I get x goes away over here. We have y by itself is less than or equal to negative x plus 6. So that's in slope-intercept form now. Let's do the other one. 2x minus y is greater than 4. I'm going to subtract 2x from both sides, and that leaves a negative y is greater than negative 2x plus 4. Now we're still looking for y, so we still need to do some adjustment here. We need to divide by negative 1. That means we're dividing everything by negative 1. And when we do that, remember, we're dividing by a negative, so we have to turn our inequality around. So now it's less than, and negative 2x over negative 1 is positive 2x, and positive 4 over negative 1 is now negative 4. And so there's our two inequalities, and so let's go ahead and graph them. I'm going to change my pen to red. And the first one starts at 6, so I'm going to go ahead and put a dot at 6, and our slope is negative 1, so it's going to be down 1 over 1, down 1 over 1. Negative x plus 6 is going to look like this, and it's a solid line because of the less than or equals to sign. So I'm just going to go ahead and draw that so that it goes straight through 6 and move it into place. And there's our graph of that. Now let's go ahead and do some shading, but I'm going to do the shading in the way that I've taught you, where I want it to be nice and light. So we're going to go ahead and put in the origin 0, 0, where y is equal to 0 when x is equal to 0, and plus 6. So this reduces down to 0 is less than or equal to 6. Is that true? Yes, it is. 0 is less than 6, and so that means we're going to shade in the direction of the origin. And so shading is going to happen with just lines, making a nice light shading. And it's important to stay nice and light like this because we're going to be shading multiple times. And as we do that, the light shading will just help us to determine. The next thing we're going to do is graph now the other line, y is less than 2x minus 4. Now remember, that one says less than only, and so it's going to be a dashed line. So I'm going to go ahead and change the color that I'm shading in. Let's do a blue. And let's go to negative 4. So we're going down to negative 4 on the y-axis and put a point there. And we have a slope of 2 over 1, right? So we rise 2 and go over 1. We rise 2 and go over 1. rise 2 and go over 1. That means I can also go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. So now if I'm graphing, I'm going to dash because of the less than only, passes through -4 and continues onward looking something like that. Okay, and let's go ahead and graph it now with shading. So we're going to use the origin again because the origin is easy to identify on one side of the line. And so let's go ahead and do that. 0 is less than 2 times 0 minus 4? Or is 0 less than -4? The answer is no. So that means that the graphing then, which I'll do in blue again, and I'm just going to do in light lines, is going to go away from the origin. So the origin is where the axes cross, and notice what's going on. And I'm going to shade even further, beyond where you see the double shading. The double shading is what identifies the truth set for you. And so if we put in points, say for instance 5, -4, that's a point that's in the truth set of our system of linear inequalities. And I just wanted to make sure that you were understanding that points that are not in that region, that double shaded region, are not solutions of the system of linear inequalities. And that's what we're trying to get you to understand. This is a small list of things to think about when you are graphing a system of linear inequalities. To graph a system of linear inequalities, do the following for each inequality in the system. Graph the line that corresponds to the inequality. Use a dashed line for an inequality with a less than or greater than sign, and a solid line for an inequality with a less than or equals to or greater than or equals to sign. Lightly shade the half plane that is the graph of the inequality for each line, and colored pencils might help you to distinguish the different half planes. The graph of the system is the region common to all of the half planes. If you use colored pencils, it is the region that has been shaded with every color. I've provided a copy of this list for you just beyond the answers to the odd problems on your homework assignment. So be sure to look at this to remind you of the steps in graphing. So let's go to example 1 now and graph a system of two inequalities. So here we have two lines, and they're already written for us in slope-intercept form, so this should be pretty easy to follow. Let's go ahead and graph the first one in red, and we're going to put a dot where we know that the y-intercept is. That looks like it's going to be at -1. So there that is, and we're going to go down 3 and over 1. 1, 2, 3, and over 1, and down 3 and over 1. And let's go ahead and draw a solid line because it's greater than or equals to that passes through all those points. And then we're going to shade. So in order to shade, we need to test. So I'm going to test using the origin. The origin is 0, 0, and we're going to say, is 0 greater than or equal to -3 times 0 minus 1? Well, let's see. Or is 0 greater than or equal to -1? Yes is the answer to that. And so when we shade, we're going to go in the direction of the origin. So there, I'm going through the origin there, and we're going to just continue our shading. We're just going to use lines because this represents a light shading. So here's our lines representing the graph of the inequality representing that first line. Okay, we're going to do now the second line, and the second line is y is less than x plus 2. So I'll change my color of my shade. We'll go for a blue, and we're going to go to +2 and put a dot there to represent that we go through 2. We have a slope of 1, which means we go up 1 and over 1, and I'm just going to put a few points in to help me with that. And we're going to dash the line this time as we graph it, and there I have a few extras that I need, and we're fine. So we're going to put a dashed line in that represents our inequality because it's less than only. So there's my dashed line, and I'm going to shade now. So we're going to use once again the origin. So we're going to say, is 0 less than 0 plus 2, or is 0 less than 2? The answer is yes, and so we're going to shade once again in the direction of the origin. So here we go. The origin is below the line, and so we're going to just put in our light lines, and so far until just recently, we just are now double shading a portion of the graph. And this is telling us the double shaded portion is the solution set. And so I can actually take any point. Let's take, for instance, 4, 0. So I'll put a nice size dot on 4, 0 and show you that, yes, that's in the double shaded region. And we could even test 4, 0 to see that it really works too. So for instance, 4, 0 means 0 is greater than or equal to negative 3 times 4 minus 1. Negative 3 times 4 is negative 12. Minus 1 is negative 13. And is that less than or equal to 0? It is, and so that's true. Now let's test the other one. Is 0 less than 4 plus 2? 4 plus 2 is 6. 0 is less than 6, and so that just shows that something there works. Let's do another example here. Here I have two linear inequalities in standard form, so we're going to have to transform them a little bit so that we can graph them using the slope-intercept form. So the first one says x plus y is greater than negative 8, and I'm going to subtract x. That makes x go away over here, and I have y is greater than negative x minus 8. And the other one is going to be x plus y is less than or equal to 6. And so I'm going to subtract x again, subtract x. X goes away here, and I have y is less than or equal to negative x plus 6. So let's go ahead and graph those now. The first one I'll graph in red, and y is greater than negative x minus 8. That means I'm going to go all the way down to negative 8 and put a dot there. And I know that the slope is going to give me a point up there at x equals negative 8 as well. And so I'm just going to go ahead and draw a dashed line to show the graph of y is greater than negative x minus 8. So there that is. Let's go ahead and shade it now properly. So let's see, is 0, 0 going to be a solution here? So let's test that. Is 0, 0 going to work? In other words, is y going to be 0 greater than negative 0 minus 8? Is 0 greater than negative 8? Yes, it is. So we can go ahead and shade now in the direction of the origin again. So here we go. We're going to shade in the direction of the origin from the line. So here we are. And there's our shading. Light shading using lines. And there we go. So now let's graph the other line. We'll graph that one in a blue. And we're going to start off by putting a dot at y equals 6, because we're looking at y is less than or equal to negative x plus 6. So we know that's going to cross at 6. It's also got the same slope of negative 1. So that means we're going to go ahead and put a point like that right there. And I'll put a couple extra points to help me draw this. And we should be able to draw a solid line because it's less than or equal to that passes through 6. Now, the question is the origin a solution to this inequality? Or is 0 less than or equal to negative 0 plus 6? Is 0 less than or equal to 6? Yes, it is. So we're going to go ahead and shade now in the direction of the origin. So from the line going in the direction of the origin, our shading now looks like this. And so as I'm shading, I want you to notice that there is only one part that is double shaded by the way that we're graphing it. And that's the part that's in between the lines. And so we could go ahead and say, so here is our solution set then, everything that's in between these two lines. And we can even test, well, we already tested that 0, 0 works, but let's just go ahead and test something else. Let's test like is 2, negative 4, for instance. Is that a point that is a solution to these lines? 2, negative 4. So x is 2 when y is negative 4. Let's go ahead and test that. 2 plus negative 4, is that greater than negative 8? 2 plus negative 4 is negative 2. Is that greater than negative 8? Yes, it is, because 2 is further to the right on the number line than negative 8. Let's do the other one. 2 plus negative 4. Is that less than or equal to 6? So 2 plus negative 4 is negative 2. Is that less than or equal to 6? It's less than, so sure, that makes that a point. Here's another example, and you're going to see why this one is an interesting one. So I have an example of graphing a system. We already have these in slope-intercept form, and so they're going to be easy to graph. The first one is y is greater than 2/3 x plus 3. So let's go ahead and graph that. Point at 3 on the y-axis is right there. And our slope is 2/3. So we're going to go up 2 and over 3. Up 2 and over 3. 1, 2, 3. Puts me like right there. And I'll put in a few more lines to help me, points to help me graph this. And this one's going to be dashed. So there's that graph right there. And the other one is going to be y is less than or equal to 2/3 x minus 4. So we'll do that in blue. And we're going to go down to -4 and put a dot there. And we're going to go, same thing, up 2 over 3. So up 2 over 3 and up 2 over 3. And it looks like we're going to have a line that goes through like that. And it's a solid line because this one is less than or equal to. Now let's go ahead and do our shading. So for the first line, using red, I'm going to go back to a red pen for my shading. The origin. So we're going to go 0 greater than 2/3 times 0 plus 3. Or is 0 greater than 3? 0 is not greater than 3. So we'll go back to red pen here. We're going to shade everything away from the origin on our line with nice light shading from the line away from the origin. And there we go. Let's go ahead and check the other one out. We're going to do that one in blue, but let's test first. Let's test the origin again. So we're going to use 0. Is that less than or equal to 2 over 3 times 0 minus 4? Is 0 less than or equal to -4? Well, it's not equals, and it's not less than, so we're shading away again. And so here we go. We're going to shade away from the blue line, away from the origin, and our shading now looks like that. So the question becomes, do we have a solution at all? Is there a solution set? Is there any part that is double shaded? And we have the 3 regions. Here's region 1, here's region 2, and here's region 3. The reason why that happens is because we have parallel lines. You can either be between the parallel lines, or you can be above, beyond the 2 parallel lines, or you can be below, beyond the 2 parallel lines. So in this case right here, since we don't have anything that gives us truth, there is no solution. And so there you have it. That's how to graph systems of linear inequalities. Your homework is going to be all the problems on a two-sided worksheet. I've provided you with solutions to the odd ones to help you see what correct answers look like. And I've also provided you with a list of things to guide you in graphing and solving systems of linear inequalities. If you need help on any of this homework, remember that I am available during study hall Monday through Friday from 2 o'clock to 3 o'clock in the afternoon. Just let me know you are coming using email, or simply show up and take your chances that I'm not already helping someone else. The meet code is found in the stream on Google Classroom. You can look it up there.